Okay, so now we're going to do essentially the sketching problem, but I'm not going to do the sketch itself. I'm going to find the intercepts, asymptotes, extrema, and inflection points of this function. Okay, and I could then show you what the graph would look like. Okay, so here are my intercepts. First, my domain is obviously all real numbers because this is a polynomial. So the intercepts, the x-intercepts would be when y is 0. So I'm going to have to do 2x cubed minus 3x squared minus 12x equals 0, which would give me x times 2x squared minus 3x minus 12 equals to 0. Then this would give me x equals 0 as a root. Then I would need to do x equals negative b, so 3 plus or minus the square root of b squared, 9, minus 4ac, which is going to be 4 times negative 12 times 2 all over 2a, so 2 times 2. And this is going to end up giving me 3 plus or minus the square root of 105 over 4. And so if I did want to sketch this, I could approximate that would be about 3.3 and negative 1.8 if I go ahead and calculate those. Okay, y-intercept is going to be x equal to 0, but in that case I would just get y equal to 0 because if I plug 0 into there. Alright, so I had my x-intercepts of 0, 0, approximately 3.30 and approximately negative 1.80, and my y-intercept is 0, 0 because if I have the origin, then I have both that as an x-intercept and a y-intercept. Okay, whoops, let's go to asymptotes. Alright, so with the asymptotes, if I look back at this function here, I notice that it is a polynomial, which cannot have any vertical asymptotes. Now, if I wanted to talk horizontal asymptotes, again, I would have to look at the limit as x approaches infinity and the limit as x approaches negative infinity of this 2x cubed minus 3x squared minus 12x. 2x cubed minus 3x squared minus 12x. 2x cubed minus 3x squared minus 12x. Okay. So this one, as x goes to infinity, is going to go off to infinity. This one is going to go to negative infinity because the x's in there are getting cubed, so the negatives remain negative. Alright, so there are no horizontal asymptotes, but I do know that my ending up graph goes up this way and down this way from these limits. Okay. Let's go to the extrema now. So I'm going to need my derivative. So f prime, okay, and that's just going to be 6x squared minus 6x minus 12, which is 6x squared minus x minus 2, or in other words 6x plus 1 x minus 2 Okay, So then I ask, when is f prime equal to 0, or when is f prime undefined? It's obviously equal to 0 at -1 and 2, and it's not undefined anywhere. So that, charting this, I'm going to put -1 and 2. I don't have any discontinuities to put on. So on my derivative chart, if I plug in -2, I'm going to get negative times negative is positive. Plug in 0, I'll get negative. Plug in 3, I'll get positive. So here's where we have f increasing, f decreasing, f increasing. And because of what I'm seeing, increasing then decreasing, here I have a relative max at -1 something. And here, because of the decreasing then increasing, I have a relative min at 2 something. So I would need to know what the function is at -1 and 2. And if I put in x of -1 and x of 2, if I put in -1, you should get 7. And if I put in 2 into here, you should get 20. So there I get my relative max at -1, 7, and my relative min at 2, -20. Okay, so I should denote some of these things that I found. Okay, so now, let me split here. I need to look for some inflection points. Okay, so I'm going to need the second derivative, which is, where's my first derivative? Here. So my second derivative is going to be 12x minus 6, which is 2x minus 1. And my second derivative is 0. And my second derivative undefined, I ask those questions. X equals 1/2 is where it's 0, and it's not undefined anywhere. So I'm going to put 1/2, whoops, 1/2 there for my second derivative. Find out signs of this. When I'm at 0, this ends up being negative. When I'm at 1, this ends up being positive. So here is where f is concave down. Here is where f is concave up. I have a change in concavity at 1/2, a point on the curve. So this is my inflection point at 1/2. And if I were to plug in 1/2, what you're going to get is -13/2 out of that function. And so there's my inflection point. Alright, so I had no asymptotes, I had those intercepts, I had a relative max and a relative min, and I had an inflection point, and although it wasn't specifically asked, let's take a look at this. Alright, so 1, 2, 3. 1, 2, 3, 4, 5. Okay, so we had 0, 0. We had about -1.80, and we had about 3.30 as our intercepts, and the 0, 0 also is a y-intercept. No asymptotes, but we know how it ends up. A relative max at -1, 7, so let's call that -1, 7, and a relative min at 2, -20. Alright, so 2, let's call that 2, -20. Let's extend that a little further. Okay, and Then we have an inflection point at 1/2, negative 13/2. So let's call that negative. That would be somewhere down here. So let's put it about there. So let's call that the 1/2, negative 13/2. All right, and so I know that this must top out here, must bottom out here, goes through there. That's where it changes concavity. It's got to come up here, go through and go up, come down here, and go down. And that's my function's graph.